Cars make our world run smoothly and efficiently, making our lives easier. But how exactly do cars work? How is it that the simple spinning of a tire can propel a car forward and send us where we need to be? Today we will investigate how Newton's laws pertain to car tires and essentially make the world run. Newton's first law states that an object in motion will remain in motion at a constant velocity until a net force acts on it, and the same applies for an object at rest, which will remain at rest. This can be seen when a car is rear-ended while sitting in traffic for hours. The car is not in motion and will remain in this position unless a car behind it bumps into it. Newton's third law states that if object A exerts a force on object B, then object B must exert a force of equal size and opposite magnitude back on object A. This means that in order for the car to move forward, it has to push the ground backwards. Wait, the car pushes the ground backwards? How does that make any sense? This can be proven through a car driving on a gravel road. You know that the car is pushing the ground backwards because some loose pieces of ground fly up behind the car. The car pushes the ground backwards and the ground pushes the car forwards with an equal and opposite force. Well, if the forces are equal and opposite, then why don't they cancel each other out? This is a common misconception. The forces are acting on different objects. The tires apply a force to the ground, but the ground applies a force to the tires. Then why doesn't the ground move? This can be explained with Newton's second law. Newton's second law states that the net force acting on an object in a single dimension is equal to its mass multiplied by its acceleration. If we return to our example of a car driving on a gravel road, this law becomes much clearer. We know from Newton's third law that the force of the car on the ground is equal to the force of the ground on the car. The mass of the car is much greater than that of the piece of gravel, which means that the acceleration of the car is much less than that of the gravel. But how can this law explain why the Earth doesn't move? The net force is present, but the large mass of the Earth means that the acceleration of the Earth is very small, almost negligible. This means that yes, you can move the Earth all by yourself, however it is so minimal it is unnoticeable. Although car tires are great and make our lives run smoothly, they do have their disadvantages too. Since the tires on cars are the ones applying the force to the ground to make the car go forward, they go through a lot of wear and tear damage. If you drive, then you would know that tires wear out regularly and must be changed often. Well, then what happens to the old tires? Canada and the US combined accumulate 275 million used tires every year. Scrap tires left in piles can catch on fire easily, resulting in a lot of pollutants being released into the air. Not only that, but burning tires can also leak oil and aromatic hydrocarbons into the soil. And because of runoffs, this can contaminate lakes, rivers, oceans, and as a result, our drinking water systems as well. Tire manufacturers realized this problem and tried to resolve this issue by reducing tire waste, so they made tires that last longer. However, these tires are also problematic because when they break down, they disintegrate into tiny airborne particles known as tire dust. Not only is tire dust an allergen because it is made of latex, but it is also the reason why so many people have asthma nowadays, because tire dust is so small and can be breathed deeply into the lungs. A solution for this is public transit. For example, if thousands of people have to travel into a great big city like Toronto every day to work, then it makes sense for them to all take the same vehicle. If everyone drives their own car, then in F net equals ma, the masses would be cars plus people times 1,000. However, if 1,000 people take public transit, then their mass would only be the mass of the 1,000 people plus a few public transit vehicles, whether that is by bus or train. However, since the total mass is significantly reduced, the force the wheels have to push back on the ground for an X amount of people will be significantly less than those people in their separate cars combined. Additionally, if people are encouraged to ride public transit, and public transit is built to be more accessible, then there will be less wheels on the road, which means less wheels are damaged and have to be changed every year. This phenomenon of public transit is already happening in many of the world's largest cities. What is important is to emphasize this importance to global leaders and persuade them to take further action.